Alright, so we're going to review real quick. For number one, we're going to go over what we learned last time, and that's writing these chemical equations. Okay, so if you guys remember last time, we talked about how chemical equations are like recipes, right? It's on the left side of the arrow, we write down the reactants, or the starting chemicals, and then we draw an arrow, and then we write down the products, okay, which are the chemicals that we make. So this is what we talked about last time. And so we're going to write the chemical equation for this reaction right here. So the key thing to identify is what do we start with and what are we making. So if we take a look at this equation, it says plants use CO2 and H2O to produce this chemical right here and O2. So if we read the sentence, what are the chemicals that we are starting with? Yeah, CO2 is one of them, and then H2O, yeah. So these are the two chemicals that we are starting with. So these are the reactants. So we're going to write CO2 plus H2O. And then we're going to draw an arrow to indicate that these chemicals are reacting to make a new chemical. Alright, so if we take a look at the rest of the sentence, it says they are producing C6H12O6 and O2. So you're making these chemicals. So you are making C6H12O6 and O2. So this is going to be the chemical reaction or equation for this one. Yeah, what's up? Go ahead. Alright, so before we move on, we're going to just kind of go over a couple things that we're already familiar with. We are pretty familiar with writing these formulas for these molecules, right? And what these formulas tell us is it tells us what the molecule is made out of. So for example, CO2 is made out of carbon and it's made out of 2 oxygen. So these three elements are combining and they are making this one molecule. That's what this formula tells us. It tells us what the chemical is made out of. Now, what we're going to be doing today is we're going to be looking at these formulas a little bit more in detail. So we're going to be reviewing. So I want you guys to take about a minute or two. I want you guys to write down these formulas on your paper. And I want you to list what elements are inside these chemicals and how many of each. We did this back in like September, so it's been a while. But I want you to write these two formulas and figure out how many elements are in each chemical. So you're finding out how many elements are in H2SO4, and you're also trying to figure out what elements are inside of Ca parentheses CN2. So take about a minute or two to do that. You can work with the person next to you, and then we'll go over it, and then we'll get into the actual new information for today. All right, everybody, let's go over this and then we'll move on to the new info. All right, so for H2SO4, we're looking for the capital letters. Okay, so capital letters are going to be H. So that's going to be our first element. We got S and we got O. Okay, so HSO. Those are the three different elements inside of this molecule. Again, look at the capital letters. All right, now for how many there are, we're going to look at the number behind the element. So H has a 2 behind it. That means there are 2 H's inside of this molecule. Okay, S has no number behind it, which means there's 1 S. And then for O, there's a 4 behind it, which means there are 4 oxygens. Okay, so that's how we count the elements inside of the molecule. All right, let's move on to the other one. This one's a little bit weirder because there's a parentheses, but we talked about this before, so let's see if you guys remembered. In terms of the actual elements, we have Ca, we have C, and we have N. Those are the capital letters, and those are our elements. If you look at Ca, there's no number behind it, so you got 1 calcium. And then we got to do the thing in the parentheses. Now, parentheses is pretty easy. Basically, the number on the outside, it's like math. You're just distributing it to the number or to the elements on the inside. So if you look on the inside, there's a carbon with no numbers. That's 1 carbon. And then times 2. So there are 2 carbons. Same thing with the nitrogen. There is 1 nitrogen times 2. So there will be 2 nitrogens. So that's how you can count up the elements. Yeah, what's up? Alright, so today what we're going to be doing is we're going to be looking at these chemical equations a little bit more in detail. So we're going to be learning how to draw these things called bubble diagrams, and that basically is a way for us to visualize what is happening to the molecules when they mix together. So just to put it very simply, when chemicals react together, the elements, so like the hydrogens and the oxygens, they basically rearrange to form new molecules. And that's what we're going to be visualizing today. So on your papers, before we start, I want you guys to write down this equation for number 3. And then I'm going to show you guys how to draw the bubble diagram for that. So right now, take a minute and just copy down this equation. Alright, so we're going to look at this reaction, and what we want to do before we draw our bubble diagram is just identify what molecules we have. Okay, so we're going to look at the equation. Alright, so you want to identify what molecules there are. So first molecule is H2, right? So we're going to draw H2. Now if you look at H2, H2 is made out of hydrogen, right? How many hydrogens are inside of H2? 2. So what we're going to do is we're going to draw 2 circles. And we want them touching each other because they're combined inside of 1 molecule. And we're going to write H inside of them. And that is to indicate this is 1 molecule, it's H2, and it's made out of 2 hydrogens. Okay? Alright, let's go to oxygen now. Oxygen is also made out of 2 elements, right? But this time it's oxygen. So we're going to draw 2 circles, same thing, and they're combined together. But this time we're going to write O inside of them to show that it is oxygen. So this is a picture of H2, and this is a picture of O2. Okay, so that's what a bubble diagram is. It's just us visualizing what does the molecule actually look like, what elements are making them up. No, it goes more into we get into more detailed pictures. It's like the most simple picture we can think of. Yeah. Later in the year, we'll draw more complicated pictures, more accurate. Yeah. We are going to draw the product. Yeah, we're not there yet. Alright, so let's draw the product. So we are combining H2 and O2, right? So we're going to draw an arrow to show that they are combining. And the chemical that they make is H2O. So H2O is made out of 2 hydrogens. So for me, it's the red circle. So we're going to draw 2 red circles, and they're stuck together. It's the same molecule with oxygen. So this time, we're going to have a blue circle also connected. And that's going to be our oxygen. So H2O is going to look like this. 2 hydrogens and 1 oxygen. It's just the formula. The formula is H2O. That's why. It's just the way it is. Yeah. No, it's okay. It's a fair question. Yeah, great question. So the orientation doesn't matter. So I drew it like this. But if you drew H2O like H, H, O, that's fine. If you drew it like this, like H, H, O, that's fine. As long as you have 3 circles, 2 H's and 1 O, and they're stuck together, it's fine. Yeah. So yeah, great question. The way that you draw it doesn't matter. It's just what it's made out of matters, and that they're all stuck together. All right, so if we take a look at this bubble diagram, what this shows us is that the H and the O, this H2 and O2, they combine and they rearrange to make this molecule right here. So that's what the elements are doing. They are rearranging to make new molecules. Now, before we move on, we're going to do something that's going to lead into the next lecture that we do. And what we're going to do is we're going to count how many H's are on the left side, how many O's are on the left side. So let's count the elements. So if you look at H, how many H's are on the left side of the arrow? 2. There are 2. Okay, so 2 red circles, so there are 2 hydrogens. All right, if we take a look at O, how many O's are on the left side of the arrow? 2. Same thing. Good. So all we're doing is we're just counting the bubbles. If you want to count the bubbles, great. If you want to just look at the formulas, you could do that as well. All right, let's look at the right side now. I'll give you guys 30 seconds. I want you to write down how many H's and how many O's are on the right side of the arrow. So just jot that down on your paper, and then we'll go over it, and then it'll kind of lead us into our next point. All right, guys, so let's look at the right side of the arrow and count the elements. Okay, how many hydrogens are on the right side of the arrow? Not 4. If you look, how many red circles do you see? 2. So there are 2 hydrogens. And how many oxygens are there? 1. Good. All right, so that's how you can count up the elements. All right, so that's how we count the elements. Now, if you notice, there is something wrong with the count, right? There's the same number of hydrogens on both sides. But if you look at the oxygens, there's a different number of oxygens on the left and the right side. Okay, when there's a different number of even one element, we call this an unbalanced equation. So just jot that down on your paper and put a box, maybe box it. This is an unbalanced equation. What this means is there's an imbalance, right, of elements on the left and the right side. So this is actually a problem that we're going to learn how to solve in the next lecture. But for now, we're just learning how to identify if there's a problem or not. So this equation, the problem is you don't have enough O's on the right side of the arrow. Okay. So that's what you'll be doing today. You'll be mainly drawing these bubble diagrams, and then you're just going to identify, is it unbalanced or is it balanced? Exactly. So I'm not going to teach you guys how to fix this problem this class, just how to identify it, but let me show you guys how we can fix this unbalance. Okay, so the way that we balance these equations, I want you to write this word down, coefficients. Okay, we do this by adding coefficients to the equation. And you might have heard that term in algebra. It kind of works the same way in chemistry. But for now, just write down this word coefficient. And then I want you to write the equation for number 4. It's very similar to number 3, but there's going to be a little bit of a difference. So right now, you're going to be writing the word coefficient, and then copy down this equation. And then we'll take a look at this and see how this fixes our equation. So in math, coefficient is the number that goes in front of a variable, right? So if you have something like 2x, the 2 is the coefficient. It's the number in front of a variable. Well, in chemistry, it's very similar. The coefficient is just going to be the number that's in front of the chemical in an equation. So the coefficient here is 2. Coefficient here is 1. Coefficient is 2. Okay, so what we do to fix these equations is we add these coefficients, and that allows us to fix our unbalanced equations. And again, I'm not going to teach you how to add the coefficients. We're going to learn about that next time. For now, we're just going to learn how to identify the coefficients, all right? So we're going to do the same thing we did for number 3 with number 4. We're going to draw a bubble diagram, and we're going to identify if it's balanced or not. So let's take a look at number 4. Same chemicals. First chemical is H2, right? So we're going to draw H2 again. So let's draw H2. It's going to be 2 circles, and they have hydrogen. All right, now the difference in this equation, if you look, there's a 2 in front of H2, right? What this is telling us is that there are 2 of them. Yeah, so you're going to draw another one. That's what that 2 means. It just means that there is a separate H2. Okay, if you notice, these are not stuck together because they are separate molecules. You just have 2 separate H2. If you connected them all together, that's not H2 anymore, that's H4. Okay, so H2 is when it's just 2, and the 2 in the front separates them from each other. Okay, O2 has a 1 in the front, and so we're just going to do the same thing as the last problem. We're going to draw 2 circles, and it's going to be O. And then, yeah, and then let me give you guys a minute, see if you guys can do the product side. I want you to draw 2 H2O. So for the 2 H2O, same thing as before. H2O is 2 hydrogens and an oxygen. Okay, so we're going to draw H2O. But if you look, there's 2 of them, right? So you just need to draw the same molecule twice. But just remember, they are separate. It's the same thing, but they are separate from each other. It's not the same molecule. It's not all connected. You have two separate H2O molecules. Okay? All right, now let's see if this fixed or balanced our equation. Let's look at the left side of the arrow. How many H's do you see on the left side of the arrow? Yeah, there's 4 of them now, right? So there's 4 H's. And then for the O's, there's still 2 of them. And then on the right side of the arrow, how many H's do we have? 4. And how many O's? 2. 2 blue circles, so 2 O's. And if you guys see, now it is balanced, right? So we're going to write that this equation is balanced. Yeah, what's up? Correct, yeah. Yeah, so I think the easiest way to draw these is first ignore the numbers in the front and just draw this molecule first. And then after that, look at the number, and then you just draw it that many times. If it's 1, you can draw it once. If it's 2, you draw it twice. If it's 3, 3 times. I'm not going to give you big numbers. I'm not going to give you like 15 or anything like that. All right, so you guys can see how by adding these coefficients, the numbers in the front, we can balance the equation, right? And again, that's what I'll teach you how to add the numbers later. But for today, you're just going to be learning how to interpret this and figure out if it is balanced or not.